Step 5.4 Algorithms with Integrated Variable Selection. First, we want to look at biclustering algorithms. Biclustering algorithms are implemented in package Biclust. So this is a contributed package, so you'll need to install it first before you're able to load and then use it. And we'll be using the also active dataset from package MSA. So we're loading that dataset, and then we can run the biclustering algorithm on it. So function Biclust does this for us from the package Biclust. Here is the dataset. We use here a binary data matrix where we have in the rows our respondents, our consumers, and in the columns there are our variables, the segmentation variables or the activities they engaged in. And there are different biclustering methods implemented in package Biclust, and we'll be using the one which is presented in the book, which is suitable for binary data and does this iterative process of first looking for one group of respondents with certain characteristics, then taking this group of respondents out and then continue. So we don't have any overlap of respondents being assigned to several clusters or segments. So this method is implemented in the function bcrep_bimax, but package Biclust would also allow you to use different biclustering algorithms. And we set a number of parameters for this algorithm. Min_c means what's the minimum number of columns which a cluster needs to contain to be identified as a cluster. Min_row is the number of rows or respondents a cluster needs to contain to be identified as a cluster, so that's the segment size. And here number is the maximum number of clusters we're looking for. This is not this is an upper bound which is not hit by the algorithm, but it might be safe to include so that the iterative process terminates at a certain point. And max_c is the maximum number of columns we want to include in a segment. And here also the upper bound is not hit by the algorithm. So we run this and we'll need to wait a little bit until this finishes. So this algorithm is a very efficient one, but still computationally rather intense, so it takes some time to run. So once the algorithm finished, it returns an object of class Biclust, which is now saved in ausact.bsc, and this contains the information which clusters were identified, and for each cluster it contains the information which rows and which columns are assigned to that cluster. The easiest to see what the segmentation solution looks like is to use a visualization. So we'll use function Biclust_member to visualize the cluster solution. And this uses as input the dataset, and then the second input is our fitted model. We don't want to have a title for our plot, and we want to have a label for the x-axis, and the coloring here means how our variables which are identified using the segmentation base, what color is used for them, and what color is used to indicate the population agreement level with any of these binary variables. And for this we use a sequential palette. Sequential palette means it goes from blue to white and steps one by one. So we have a color vector of length 100, which goes gradually from dark blue to white, and we are reversing the vector because we want to indicate that if there is a 0, this means white, and if everyone indicates yes, that should be in blue. And we're changing the margins in our plotting window using par because we want to have more space to the left to the right to indicate the variable names. So let's have a look at the result. We zoom in. So we see we have more margin to the left and the right. So we could put in the names of our variables. And on the x-axis here we have the number of segments which were identified using our biclustering algorithm. So we have 12 segments identified. And for each segment solution, the blue cells, the colored cells here indicate which variables are in that cluster. So these are indicated by dark blue. So this is segment 1, the activities it does is relaxing, eating, shopping, and so on and so forth. And the middle color here indicates what's the population average. So we have a darker blue color here for relaxing, meaning that relaxing is something a lot of people in the total population do. And we also see we have rows where there's no colored cell at all. This means that these variables are contained in none of the biclusters we have identified and thus are sort of excluded.